Welcome back to BaseSpice. In this session, we'll continue with hookup drawing, wherein we'll focus on the flow meter. So, flow meter in the sense that we see all the types of flow meter, like basically the inline meter, like Mach flow, vortex, thermal mass flow. All this we will see the hookup. Okay, so this is the look and feel of one of the Mach flow meter actually. Okay, so in this session, we will be talking about Mach flow meter, vortex flow meter, mass flow meter, and thermal mass flow meter. These are the four aspects we are going to cover. So let's go into the the hookup drawing. Yes, so this is the hookup drawing for the Mach flow meter. Okay, friends. So yeah, again, I will go one by one. As you can see here, the number one, basically the number one is nothing but the process pipe, that is by the piping scope, piping scope. And number two is a mating flange, gasket, everything. So that also by piping scope. As you can see here, this one, mating flange, gasket, nut bolts, all by piping. Okay, then comes this number three. So this is the Mach flow meter. Exclusively, we need to manage this instrument scope. Number three, this is the instrument scope. Then additionally, we have a cable gland and a signal cable. This is signal cable and power cable. You know, right, friends? This is a four wire actually. So that is why I shown here. If it is two wire, then only the signal cable. Okay, that's it. Everything together in the same cable. So this is about the Mach flow, and in fact, if you see the the upstream and downstream fronts, most of the Mach flow, right? The E and H or Corona make all these. We need 5D and by 2D, downstream 2D, upstream 5D. But the point to note here is, friends, just for your info, nowadays we have a 0 DN flow meter also, meaning we don't have to have this 5D and 2D. So even without a 0 DN, I mean, without DN requirements, we can mount it. But only thing is, accuracy point of view, what I observed is slightly different, slightly higher than the, this type of flow meter. Okay. So you can also watch, I mean, you can also, inquire, and if anything, you can comment on this video. Okay. This is about the Mach flow. Then we'll go into the I think I need to flip this again, friends. Just allow me to flip back. Yes, yes. So this is about the vertex flow meter. Okay. So again, as I said earlier, vertex, I didn't put this upstream and downstream here. You see, for upstream and downstream, we need to refer the other sheet. I will also explain that later. So coming back to this hookup, 0, 1, that's a pipe. Again, it's a piping scope. Okay. And number two is again the, mating flange and the gasket, nut bolt, all these by piping scope. Then we have this vortex flow meter. This is how we represent actually. So number four is the cable gland and number five is the signal cable. Okay. So that's all, friends, about this vortex actually. This is how we need to represent. Okay. And yeah, we will talk. Okay. Proper support to be provided at upstream and downstream to reduce the vibration, that we need to take care. And while installing, ensure that the line is always filled with liquid, and flow meter should be installed at accessible location, of course, right? And for upstream and downstream, we need to refer the other sheet. I will also take you through. So this is the look and feel, friends. Again, friends, for every vendor, they have the different, upstream and downstream requirement. So this is something like a, like a guideline. See, for example, this is one type actually, 15 DN by 5 DN. Okay. And this is another type, 18 DN by 5 DN. Okay. And here 20 DN. So you may be wondering why it is, because, see, as a minimum, the inlet and outlet run shown below must be observed to achieve the specific accuracy of the device in line with the manufacturer recommendation. So the point to note here is the longest inlet run shown must be observed if two or more flow disturbances are present. So that is why this 20 DN. So here it's a 15 DN, here 18 DN, but here it is 15 DN. I mean 20 DN, meaning there is a flow disturbance in the bend. So that is why. And if you see here this one, too much, right? So that is why it is 40 dn. So that's why. So the more the number of bends, the more the number of disturbances, the more the dn upstream side. That is the what you call. That is what I want to put forth by this diagram, friends. Similarly, for in this case, you see 25 dn here also, and here if it is after the control valve, even more disturbances. That is why 50 dn upstream. Okay. So yeah, that's it, friends. Okay. This is about the vertex. Okay. Now I go into the mass flow meter. Okay. I will flip again this, to, yeah. Okay. So this is the mass flow. Again, if you see the diagram, this is your pipe process line. And number two, this is your mass flow. Okay. And very specifically, we need to see here. Yes. Yeah. And yeah, this is the mass flow. Yes. And what is this? Number three, number two. Yeah, number two is mating flange and gaskets. Number three, of course, mass flow meter. Number four, again, is a cable gland. Number five is a signal cable. And number six is a power cable. That is the configuration. Same as actually your Mac flow. But only thing is this, the diagram a little bit change actually. Okay. So that's it, friends. This is for the, normal. I think this representation is for the liquid actually. If it is gas, mean this portion will go up. So that we need to ensure it. Okay. So what is that? Yeah, I think, yeah, that's it, friends. Okay, maybe I'll run through the notes also. Just allow me to flip it again. Yeah. Okay, what does the note says here? Mass flow should be installed on accessible location. Of course, yes. Mass flow meter should be installed such that the sensor tubes are completely filled with process fluid. So that is why it has to be like this. Okay, right. Okay, then I have the another one, right? Thermal mass flow. Yeah, thermal mass flow. This is the look and feel. Again, friends, if you look at the scope here, see this complete assembly, piping scope, everything by piping scope. So the number one is of course piping. Okay. Number two is a socket. Okay. This guy for installation of this flow meter. So number two, and yeah, the complete the by piping actually we see here both are in piping scope. Then of course we have the number three. This is your thermal mass flow meter. Number four is again cable gland. Number five, signal cable. And number six is a power cable, right? Yes, same. Okay. And here on specific note, socket thread shall be 20 to 25 mm, at least 1 inch it has to be. And MOC of the socket should be as per the piping spec, meaning MOC means material of construction. And thermal mass flow meter shall be installed on a horizontal line and mounting shall be from the side only. That is also we need to watch out for. And main importantly, from this guy, the upstream and downstream, this is too much actually, 20D and 10D. Of course, this is in line with one of the vendor recommendation. Okay. Yes, that's all, friends. I don't know whether you got this. This is the meaning, friends. Tapping, we need to take it from side. That's what I meant here actually. So we installed on a horizontal line and shall be from side only. Okay. Yeah, that's it. Yeah, I think that's all I have for this thermal mass flow meter, friends. Next, we will talk about flow switch. Next video. And yeah, thank you, friends. Thanks for your support and keep supporting and keep watching. See you in the next video. If anything, you can put your comment, friends. Thank you.